Hello, Selena's here with me to share another equivalence lesson. This one is going to be a lot of fun. This one is, maybe part of this will be review if you've done your lesson on parts of a trapezoid. If not, then that will be part of this lesson for you as well. If you've already done parts of a trapezoid, then this is review. But for most of you, this should all be new. We are going to look at equivalence of the figures that we see here in this plate. Selena, what do we see here?
A trapezoid.
And here?
Another trapezoid.
Okay, and what's this?
Empty rectangle.
An empty rectangle. Okay, so let's review the parts of our trapezoid before we get jumped into this. So what is this bottom here called of the trapezoid?
The major base.
The major base. Just like in our other figures, like this is the base of our rectangle, but the top and the bottom are the same in a rectangle. So they both could be the base or the side, the opposite side. Here, this on the trapezoid, this is called the major base because it's the long one. Now trapezoids also have a
minor base.
Minor base, a shorter side that's across from the major base. So we got the major base and the minor base. Okay. Now, what is this on a rectangle?
Height.
The height. And the height on a trapezoid, I'm going to take this piece out so we can look. The height on the trapezoid is found going from the major base to the minor base right there. So that line right there is showing us the height of our trapezoid. I'm going to put these pieces back in here. Okay, so we have been talking about equivalence, and we're looking at equivalence of different figures. And so we're going to look at these. But first what we need to do is we need to determine whether this trapezoid, this whole one, is equivalent to this trapezoid. So I'm going to pull this one out, and can you replace this space to see if these are equivalent? Yes, these two trapezoids are equivalent. They take up the same space. Okay, now we want to look at our trapezoids and the relationship they have to this rectangle. Okay, can you replace this divided trapezoid down here and we'll see what happens. Okay, so Selena just proved that this rectangle is equivalent to this trapezoid. Now, we need to look at the relationships between the parts of the trapezoid and the parts of the rectangle. Okay, so let's look at what makes the base of our rectangle. I'm going to put these pieces back though so we can see. I don't know if you guys can hear it on the video, but the wind is really blowing. Okay, so let's look at our rectangle base. What made our rectangle base?
The major base and minor base.
The major base and the
minor base.
Minor base. I'm going to rotate that down. Minor base. So the base of our rectangle is made by the major base plus the minor base. Okay, now when we look at what makes up the height of our rectangle,
it's half the height of the
when we take this out, half of the height of the trapezoid makes up the height of the rectangle. So we can say that a trapezoid is equivalent to a rectangle, or a rectangle is equivalent to a trapezoid when you take the major base plus the minor base for the rectangle's base, and the height of the rectangle is half the height of the trapezoid. I'm going to go ahead and write that definition out. It's going to be a long one. Oh, also, I'm going to draw the parts of the trapezoid in case you are doing that as part of this lesson. So here, I'm going to draw it pretty big. Here's a trapezoid. This is the minor base. It's the small one. This is the major base. And this dotted line is showing you the height. So if you haven't done the parts of a trapezoid yet, please add that to this follow-up because it's important that you know the names of the parts. So I'm going to give you just a minute to look at that. I will attach a picture at the end of the lesson so that you can see what your follow-up should look like. And when that picture comes up, you can pause the video and look at it. Also, I will try to attach it in our lesson page. Okay, the major base, the minor base, and the height. Okay, now here is our long definition. A trapezoid is a trapezoid and a rectangle are equivalent when the base of the rectangle equals the sum, which means added together, the sum of the major base and the minor base, and the height of the rectangle is half the height of the trapezoid. Whew. There, it all fits. That's a big definition. So what we said is a trapezoid and a rectangle are equivalent if the base of the rectangle is equal to the sum of the major base and the minor base, and the height of the rectangle is half the height of the trapezoid. That make sense? Is it a lot of words? It is a lot of words. It's hard when you are writing it out in words. That's why mathematicians love symbols, because they don't have to say all these extra words in there. Let me show you my journal entry in my math journal for this work. And I wrote the definition. I have a title. You can see. There we go. I have a title at the top of my page, and there's the definition. And there's my trapezoid and the rectangle that I made from it, cut out of scrapbook paper. And you can see, it's hard to see because I wrote in colored pencil. My parts are labeled major base, minor base, and height. It's really hard to see on there. I will post a picture of it. It's also hard to see that way, but you can see that I wrote my definition, I drew my diagram and labeled my parts, and I have an example of what that looks like. So that's what I expect for your follow-up as well, is that you have your parts labeled and a trapezoid and a rectangle that are equivalent. Remember, the equivalent symbol is our equal sign. Our equal sign. Okay, I hope you enjoyed another look at equivalence. I can't even tell you how many more equivalence lessons there are, but most of them require having more of a material in front of you. And so those ones we're not going to video for you. Those are ones that we'll explore when we're back in person. And those are the ones like the constructive triangles and all of those explorations. And there's more metal material as well. We could go into decagons and pentagons and other polygons, but we're going to save those lessons for another day. I hope that you enjoyed this equivalence lesson. Thank you, Selena, for joining us and helping us with our learning. See you next time.